So in this fifth part of the unit, I'm going to talk a little bit about Pandas' ability to do data visualization and also its way to output data, so plotting and saving. So we might want to visualize our data, and Pandas provides some really kind of nicely thought out basic visualization functions which you can get at from dataframe.plot. And generally speaking, it tries to do something sensible with your data. So for example, if I just ask it to plot, so df.plot, and then tell it I want a bar plot, so the kind parameter, and I tell it the y values, the data to plot, and I just give it a list, and I'm giving a list here of columns, of the names of the columns I want to go and put into my bar plot. And I seem to have chopped off the edge of the screen there the closed square brackets and the closed round brackets with the plot method. And you can see what it produces is a bar chart, and it tries to do something sensible. So for example, it realizes that the x-axis is going to be the rows of the data frame, and because the rows have an index which has the name, it goes and gives the corresponding name of the character there, and it labels the X label correctly. And because I'm asking it to plot several different sets of data, it thinks it probably ought to put a legend on it, and so it puts a legend on it. So it kind of does a lot of work in the background of trying to figure out what the correct thing to go and do to be most useful is. The kind parameter is the kind of key thing in telling it what kind of plot we want, and therefore what kind of bits of data we're giving it. So for example, if you want to say, well, is there a correlation between combat and power, we could make a scatter plot. So again, it's df.plot, and this time I tell it I want the kind is a scatter, and a scatter plot I need to give it x and y, and again I'm giving it x, I'm just giving it the name of a column to use for the x value, and y the name of a column to use for the y values, and you can see it makes a scatter plot, and it's given me some sensible defaults, and it's labelled the axes, and because I'm only plotting one thing, there's no need for it to have a legend, so that's all straightforward. You can also do things like switch on multiple plots. So in this case here, I've told it I want subplots, meaning I want a separate plot for each row from my data. I've told it I want 2 rows and 4 columns, and I've told it the figure size I want, and I've told it that the x-axes don't have to be all stacked up on top of each other. And you can see here what is given me. It's probably not a very sensible plot. It's a line plot of the attributes, so each column of the data set, and the x-axis is the character name. Only because there are slightly too many characters, it's gone and missed out some of the labels. So say it's perhaps not a very sensible plot, but it sort of shows you the power of things you can go and do very, very quickly and easily with the plotting functionality. It's always trying to do something vaguely sensible. Pandas is basically using matplotlib as the engine with which it's making the plots. So technically the return value from the plot function is a matplotlib axes or a list of axes in the case if you turned on subplots. And so you can then use your standard matplotlib commands can be used to go and tweak and refine the plot that's produced. So for example, here I've made a simple plot of the data, but then I've used the matplotlib, so I've collected the matplotlib axes in the variable ax. So the result of calling df.plot I've passed to ax. That's a matplotlib axes, and now I can use the matplotlib axes functions to change that. So in this case I'm just changing the x-axis angle to 45 degrees to make it fit in more easily. Finally, if we want to go and actually save the data frame out, then Pandas again has a whole built-in way it can save things, including probably most usefully Excel. So I just need to do df.toExcel and then give it the name of an Excel spreadsheet, and it will go and create, in this case, a .xlsx file. Technically, this is done by having an extra package that knows how to write Excel spreadsheets. But again, most Python distributions, scientific Python distributions, probably include the correct packages by default. Pandas can also write a whole variety of different formats. So you might include things like CSV files or JSON files, particularly useful using web applications. It can also talk directly into various sorts of databases and other scientific library formats. So some of these things are high performance data files. So particularly things like HDF or Parquet are very common formats of data files that are used in big data. It can also, however, produce it into various things you might use for text display. So markdown text, HTML, and maybe most usefully, it'll give you a LaTeX table. It's pretty unreadable LaTeX, but it does actually produce a LaTeX table for you. You could then copy and paste into Overleaf quite satisfactorily.